Last video now S block elements na alkali metals nalli some important compounds of sodium nalli sodium chloride, sodium hydroxide ಮತ್ತು ಬೇಕಿಂಗ್ ಸೋಡಾ. ನಂತರ S block elements ಗೆ ಸಂಬಂಧಪಟ್ಟಂತಹ ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ಸ್ ದಟ್ ಈಸ್ ಆಲ್ಕಲೈನ್ ಅರ್ತ್ ಮೆಟಲ್ಸ್, ಅದರಲ್ಲಿರುವಂತಹ ಎಲಿಮೆಂಟ್ಸ್ occurrence, electronic configuration, atomic radii and ionic radii, ionization enthalpy, hydration enthalpy, physical properties, chemical properties, and the uses of the alkaline earth metals, general characteristics of the alkaline earth metals ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡಿದ್ವಿ. ಇನ್ನು ಮುಂದೆ anomalous behavior of the Beryllium ಹಾಗೂ diagonal relationship of the beryllium with aluminum ಅದರ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡು ಮತ್ತೆ ಈ ಆಲ್ಕಲೈನ್ ಅರ್ತ್ ಮೆಟಲ್ಸ್ ನಲ್ಲಿ ಉಳಿದಿರುವಂತಹ ವಿಷಯಗಳನ್ನು ನಾವು ಇವತ್ತು ತಿಳ್ಕೊಳ್ಳೋಣ. Now we can study anomalous behavior of beryllium. In alkali metals we have learned lithium as the anomalous behavior, but in alkaline earth metal we are taking the anomalous behavior of the beryllium. What are the anomalous behavior of beryllium? All of us know that beryllium is exceptionally small atomic size and ionic radius when it is compared with the other members of the alkaline earth metals. Small size, atomic size and ionic radii beryllium has large ionization enthalpy and small size. Therefore, beryllium forms covalent compounds and the salts of the beryllium are easily hydrolyzed. Beryllium does not exhibit coordination number more than 4 due to its valence shell consists of 4 orbitals because n is equal to 2, whereas the other members of the alkaline earth metals they possess 6 coordination number because d orbitals are also taking part along with s and p orbitals. Beryllium oxide and beryllium hydroxides are amphoteric in nature. Now next is in alkali metals we have learned the diagonal relationship of lithium and magnesium, whereas in alkaline earth metals we are learning the diagonal relationship with beryllium and aluminum. finished the anomalous properties of beryllium. In alkali metals, that is group number 1, we have taken the diagonal relationship of lithium and magnesium. In alkaline earth metals, we are taking the diagonal relationship of beryllium with aluminium. Both beryllium and aluminium are having electronegativity values 1.5. I am representing electronegativity as En. The beryllium also 1.5 and aluminium also 1.5. Both the metals are having charge by radius ratio almost similar. If you take beryllium, it is approximately 0.064 and aluminium it is approximately 0.060. So they are similar and charged by radius ratio. Both beryllium and aluminium, they are resistant towards the action of acids because of the formation of protective oxide of film on their surface. Resistant towards acid. Beryllium and aluminium, both they form complexes when they react with the strong alkalis. Soluble complexes are formed. Beryllium forms with strong alkalis. BeOH 4 times 2 minus is called as beryllium. And aluminium forms AlOH 4 times 3 minus. Both beryllium and aluminium, they form their chlorides. Beryllium chloride and aluminium chloride, they form Lewis acid. Lewis acid. Since beryllium and aluminium, both they are having similar charge by radius ratio, they are having tendency to form the complexes. Beryllium forms BeF4 2 minus and BeC2O4 BeC2O4 twice 2 minus aluminium, it forms AlF6 3 minus and AlC2O4 has 3 minus. This C2O4 is nothing but oxide. These complexes you are studying in second period, Plaster, in coordination compounds. In alkali earth metals, that is group number 1, we have studied important compounds of sodium. In alkaline earth metals, that is group number 2, we are studying some important compounds of calcium. First compound, we are taking calcium oxide. Or its common name is quicklime. Its formula is Ca. Preparation or manufacturing. It is commercially prepared by using limestone, heated in rotary kiln. Temperature between 1070 to 1270 kelvins. So let us write the equation. Calcium carbonate, nothing but limestone, on heating around this temperature, it forms calcium oxide. This is quicklime and carbon dioxide. Let us learn the properties of the calcium oxide. But when in this calcium carbonate, on heating use of calcium oxide and carbon dioxide, the carbon dioxide that is produced, immediately it should be removed. Then properties of the calcium oxide is as follows. Calcium oxide is amorphous, white solid, and its melting point I'm writing it as Lp 2870 kelvins. When calcium oxide reacts with the atmosphere, we know that atmosphere contains moisture. So when it reacts with moisture, it forms calcium hydroxide. When calcium oxide reacts with the carbon dioxide, it forms calcium carbonate. Calcium oxide reacts with acidic oxides. Example is silicon dioxide, nothing but silicon. And also it reacts with the phosphorus pentoxide. Next property of the calcium oxide, that is when calcium oxide is reacting with acidic oxide, I am writing here, with acidic oxide, calcium oxide plus silicon dioxide, we call it as silica or silicon dioxide, it forms calcium silicate, CaSiO3, calcium silicate. It is acidic oxide, silica. Similarly, when calcium oxide reacts with phosphorus oxide, P4O10, that is phosphorus pentoxide also, forms calcium phosphate, Ca3PO4 twice. Calcium phosphate. When we balance this equation, 6CaO when calcium oxide is added with water, then it is highly exothermic in nature and also produces hissing sound. And this process is called as slaking of lime. Let us learn the uses of the calcium oxide. Calcium oxide is a main component of the cement. Calcium oxide is used in the purification of sugar. Calcium oxide is used for the preparation of the sodium carbonate from sodium hydroxide. Calcium oxide is used in dyestuffs. Second compound is calcium hydroxide. It is called as slaked lime. Its formula is CaOH twice. Let us learn the preparation of the calcium hydroxide. When calcium oxide, that is quicklime, is added with water, it forms calcium hydroxide. Properties of calcium hydroxide, let us discuss. It is white, amorphous powder. It is sparingly soluble in water. Aqueous solution of calcium hydroxide is called lime water. The suspension of slaked lime in water is called milk of lime. Chemical properties of the calcium hydroxide. When calcium hydroxide is added with carbon dioxide, it forms CaCO3 and H2O, calcium carbonate. When lime water is passed by carbon dioxide, it turns to milky due to the formation of calcium carbonate. When to this milky calcium carbonate, excess of carbon dioxide is passed, then it forms calcium hydrogen carbonate. Formula CaHCO3 twice, means the milkiness disappears or the white precipitate dissolves, forming calcium bicarbonate or calcium hydrogen carbonate. The next property of calcium hydroxide. When calcium hydroxide is passed by chlorine, it forms calcium chloride, calcium oxychloride and water. When we balance this CaOCl2 is called as bleaching powder. hydroxide are as follows. It is used in the building material, that is mortar. It is used in tanning industry. It is used in making glass. It is used in the purification of the sugar. Since calcium hydroxide is disinfectant, it is used in whitewash. The third compound is calcium carbonate, having the formula CaCO3. It is called as marble or chalk or limestone. Let us see how the calcium carbonate is prepared. Preparation. When calcium hydroxide is treated with carbon dioxide, it forms calcium carbonate and water. When it is also prepared from calcium chloride and sodium carbonate, it forms calcium carbonate and NaCl. See these two equations. In this equation, the carbon dioxide should not be passed too much, because instead of calcium carbonate, as we have studied earlier, it forms calcium hydrogen carbonate. That is why carbon dioxide is passed to calcium hydroxide in limited quantity so that calcium carbonate is obtained. Let us see the properties of the calcium carbonate. Calcium carbonate is white amorphous solid. It is almost insoluble in water. When calcium carbonate is heated at 1200 kelvins, it forms calcium oxide and carbon dioxide. Some other chemical properties also we can study now. When calcium carbonate is added with hydrochloric acid, it forms respective, that is calcium chloride, salt, water and carbon dioxide is liberated. When calcium carbonate is treated with H2SO4, sulfuric acid, it forms calcium sulfate solid, water and carbon dioxide. What are the uses of the calcium carbonate? Calcium carbonate is used in buildings. Example, our Taj Mahal. It is made out of marble, nothing but calcium carbonate. Calcium carbonate along with magnesium carbonate used as a flux in extraction of iron. Calcium carbonate is used in toothpaste. It is used as antacid. Calcium carbonate is used as filters in cosmetics. The fourth compound is calcium sulfate. In this we have taken Plaster of Paris. Plaster of Paris having the formula CaSO4 dot half H2O. hemihydrate of calcium sulfate. It is prepared from gypsum, CaSO4 dot 2H2O, gypsum, on heating around 393 kelvins, it forms CaSO4 dot H2O plus water above 393 kelvins. It loses the water of hydration, that is water molecule, and becomes anhydrous calcium sulfate. Anhydrous calcium sulfate, and this is called as dead burnt plaster. When water is added to plaster of Paris, it becomes hard due to rehydration. During the rehydration, it forms the setting of the plaster of Paris. So during the setting of plaster of Paris, about 1% expansion takes place. Therefore, it is used to produce the sharp molds of impressions where it is put in, and also it is widely used to produce the molds for industries like potteries, ceramics, etc. Let us move on to the uses of the plaster of Paris. Plaster of Paris is used for setting of the broken hand, that is nothing but fracture of the bodies. It is also used in dentistry, and plaster of Paris is used for the decorative items and also for the statues. Fifth compound in the alkaline earth metals that we are learning is cement. It is one of the most important materials that we are using in buildings, bridges, dams, etc. In 1824, the person called Joseph Asphodel, he is a mason, was working in UK. He mixed limestone, clay and water, heated and kept for some time. A hard mass obtained. It was resembling Portland rock. During those times, Portland rock were used for the building purposes. So that is why it is called as Portland cement. The average composition of the cement is as follows. See the table. Calcium oxide 50 to 60%, silicon dioxide 20 to 25%, Al2O3 5 to 10%, magnesium oxide 2 to 3%, ferric oxide 1 to 2%, sulfur trioxide 1 to 2%. For a good quality of cement, percentage of silica, that is SiO2, divided by percentage of alumina, that is Al2O3, is equal to 2.5 to 4. percentage of lime calcium oxide divided by percentage of silica SiO2 plus alumina Al2O3 plus Fe2O3 is equal to 1.9 to 2.1. Here clay contains both SiO2 and Al2O3. The raw materials required for cement is limestone, clay, gypsum, along with this magnesium oxide and also ferric oxide Fe2O3 is used to give suitable color to the cement. Now let us learn how the cement is manufactured. Limestone clay should be crushed properly and made it into powder, and it will be taken in the ratio 3:1 and mixed with water and put it in the rotary kiln. When we mix limestone clay, it is called as slurry. When slurry is heated in the rotary kiln, cement clinkers are formed. To this cement clinkers, 2 to 3% mass of the gypsum is added. Fine powdered substance comes out and it is called as Portland cement. What are the ingredients of the Portland cement? That is dicalcium silicate. Dicalcium silicate, that is 26%. Tricalcium silicate, that is 51%, and tricalcium aluminate, that is 11%. Let us learn the setting of the cement. When the cement is used, it will be added with water and forms gelatinous mass. And this becomes harder after some time because of the hydration of the constituent particles in the cement and also the rearrangements in the manner that is SiO, SiOAn. So this is called as setting of cement. To the setting of cement, a small quantity of the gypsum is also added in order to regulate the time of setting. So next, we will learn the biological importance of calcium and magnesium. Biological importance of magnesium and calcium is as follows. An adult body contains about 25 grams of magnesium and 1200 grams of calcium. The daily requirement in the human body has been estimated to be 200 to 300 mg. Magnesium is required as a cofactor for all the enzymes that utilize ATP in phosphate transfer. Magnesium is present in chlorophyll, the main pigment for the absorption of light in plants. 99% of body calcium is present in bones and teeth. It also plays important role in neuromuscular function, interneuronal transmission, cell membrane integrity and blood coagulation. The calcium concentration in plasma is regulated at about 100 mg per liter. It is maintained by two hormones, calcitonin and parathyroid hormone. The bone is not an inert and unchanging substance, but it is continuously being solubilized and redeposited to the extent of 400 mg per day in man. ಪ್ರಿಯ ಸ್ನೇಹಿತರೆ, ಎಸ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ನಲ್ಲಿ ನಾವು ಆಲ್ಕಲೈನ್ ಮೆಟಲ್ಸ್ ಹಾಗೂ ಆಲ್ಕಲೈನ್ ಅರ್ತ್ ಮೆಟಲ್ಸ್ ಗ್ರೂಪ್ 1 ಮತ್ತು ಗ್ರೂಪ್ 2 ನ ಡೀಟೇಲ್ ಆಗಿ ಕಲ್ತ್ಕೊಂಡಿದ್ದೇವೆ. ಇದರಲ್ಲಿ ಬರುವಂತಹ ಎಲಿಮೆಂಟ್ಸ್ಗಳು ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್, ಪೀರಿಯಾಡಿಕ್ ಟ್ರೆಂಡ್ಸ್ ಇನ್ ಪ್ರಾಪರ್ಟೀಸ್, physical properties, chemical properties, uses, anomalous behavior, ಹಾಗೂ the compounds of sodium and calcium, ಹೀಗೆ ಹಲವಾರು ವಿಚಾರಗಳನ್ನು ಎಸ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ನಲ್ಲಿ ನಾವು ಇದುವರೆಗೆ ಕಲ್ತ್ಕೊಂಡಿದ್ದೇವೆ. ನೀವೆಲ್ಲರೂ ಕೂಡ ನಾನು ಎಸ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಪಾಠ ಮಾಡಿದ್ದನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ ಅಂತ ತಿಳ್ಕೊಂಡಿದ್ದೇನೆ. ಹಾಗೆ ನಿಮ್ಮ ಕಲಿಕೆ ಬಹಳ ಚೆನ್ನಾಗಿ ಆಗಲಿ ಅಂತ ಹಾರೈಸ್ತಾ ಇದ್ದೇನೆ. ಜೊತೆಗೆ ಇಲ್ಲಿ ಬರುವಂತಹ ಈಕ್ವೇಷನ್ಸ್ಗಳನ್ನು ನೀವು ಚೆನ್ನಾಗಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು. ಈಕ್ವೇಷನ್ಸ್ಗಳನ್ನ ಬರೆಯುವಾಗ ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಈಕ್ವೇಷನ್ಸ್ ಬರೆಯೋದನ್ನು ನೆನಪಿನಲ್ಲಿ ಇಟ್ಕೊಳ್ಬೇಕು. ಈ ಒಂದು ಅವಕಾಶವನ್ನು ಮಾಡಿಕೊಟ್ಟಂತಹ ಕರ್ನಾಟಕ ಸರ್ಕಾರ ಪದವಿ ಪೂರ್ವ ಶಿಕ್ಷಣ ಇಲಾಖೆ ಹಾಗೂ ಉಡುಪಿ ಜಿಲ್ಲಾ ಪದವಿ ಪೂರ್ವ ಕಾಲೇಜು ಪ್ರಾಂಶುಪಾಲರ ಸಂಘ ಉಡುಪಿ ಇವರಿಗೆ ನಾನು ತುಂಬ ಹೃದಯದ ಧನ್ಯವಾದಗಳನ್ನು ಅರ್ಪಿಸ್ತಾ ಇದ್ದೇನೆ.